All right, so we're going to go pretty quickly through this somewhat review at times of how to deal with data frames in more sophisticated manners. First of all, sorting. Sorting is a really basic thing that you need to do. We're going to take a look at the CO2 data set again internal to R. There's two ways that I often go about sorting. You can use the order function. This is usually the way I go about it. And if you just run order on a variable, it gives you the position that corresponds with the elements being sorted. So if it says, say, 2, 5, 4, then it's saying the first element is the second in position. The second element is the fifth, and the third element is the fourth, and so on. Then you can use a command like this. So notice this is the vector name. Okay, so this is a vector uptake, by the way, in CO2. This is the vector name. We've ordered it, and then we're going to use that reordering to sort it. This would be equivalent to just using sort uptake, which is easy to do. However, the advantage of doing it this way is you can then take that order uptake and sort the whole data frame, because you cannot sort CO2, the whole data frame, using the sort command. That only sorts vectors. So if you use this, then it'll sort it by uptake. So then you'll have CO2 where uptake is ascending, but all the other variables are also rearranged accordingly. You can make it ascending as well. This is descending. I think I just said ascending accidentally, but this is ascending here. There's actually an option that I usually use, decreasing equal true. You can also use the reverse argument. Okay. You can sort by multiple variables, so concentration, then uptake. You can do one ascending, one descending. So this one would be descending, this one would be ascending. You can use an ordered factor, like the plant name. Okay, so this is all ways you can do sorting of a data frame. I use the unique operation a lot because it returns data frame where you don't have duplicate rows or columns. So when you're collecting data, or usually I use this in algorithm type settings where I've created an algorithm, maybe I have sets of different matches, but I realize that because of the way the algorithm is constructed, I might have some duplicate matches in there. Well, I use unique, and then I know I just have the smallest set possible of all my matches of the data. Duplicated will give you a logical vector showing you which rows are duplicates. That might be useful for you to go and investigate. By the way, you need to work this on imported data frames or other types. It doesn't work the same for data frames created during an R session. The match function is also really, really useful. So this will give you matches between variables. So if you're trying to find duplicates or find then matches across different variables that have the same information, this is a useful way to go about it. This is, I'll talk about this more in class or outside of class, but do spend a little bit of time, maybe go look at the help file with regard to duplicates and match, because it's these are both really good, useful commands as well as unique. All right, so merging, we've done this before. It's a fairly simple operation. Here's just some examples. There's nothing new here. This is just a little bit more documentation to help you do this. Reshaping. This is the one that often is very challenging, so I want to spend more time on this. If we have a wide data set, this refers to that we maybe have variables created over time, and so a unique column would be assigned to each of those variables across time, and this would be a wide version of the data set. If we want to reshape a wide, we might specify which ones are really essentially the same type of observation but just collected across time, And then we want to command it to make a long version. So what it'll do is it'll concatenate T1 and T2 with a ID variable that indicates that one is at time 1 and one is at time 2. So you can also go from long to wide. That tends to be a lot easier. You simply can run the reshape command with it long and then command it to change it to a wide data frame format. Going again from long to wide tends to be a little bit easier. You can be very specific though. For example, if you want to take this long data frame, you can create an ID variable. So that's the one that will stay consistent across the different observations by the variable name. So that will create the T.1, T.2. You can specify what the time variable is, and then again the direction. Then if you put it back, you can just reverse those commands. So this again is going from long up to wide. Here our ID variable is the same, but our variable names now are more specified. Our time variable is the same. And then here, in this case, it's easy to go back from wide to long without specifying much. Stacking, unstacking. So if you have data that needs to be unstacked, you simply use the argument unstack. The second argument's a formula to tell you how to create the groups for the unstacking. If you run this, it's fairly apparent what has happened. You can then take the unstacked version and restack it, and it will reverse the operation. You could be more specific about the stacking, so you can stack according to certain variables, or which columns, I should say. You can just stack A and B, for example. Finally, missing data. NA omit and complete .cases are the two major functions you need to know here. NA omit automatically removes your missing data. Okay, so a little dangerous, whereas complete cases will return a logical vector. We've talked about this before. This is really more of a review.